Hello everyone, Mr. Minix, my name, math is my game, and on today, as you can see in the heading, this is Chapter 5, Section 4, Polynomial Division, Part 1 of 3. In my advanced classes, I do this lesson in one day, and it really is not enough time with an advanced group. With the regular groups, I split it up over 3 days, and that's probably not even enough time if I'm being perfectly honest. But anyway, we're going to be dealing with polynomials. And what I'd like to do is I'd like to go ahead and list a few polynomials. I'm going to say let P of x and Q of x and D of x, and I know this is a lot of ands, and R of x. So let's say I got a P, a Q, a D, and an R. Yeah, be polynomials. Be polynomials. There's a reason I picked the letters that I did. P of x stands for polynomial. Now we're talking about dividing. We're talking about dividing. So if you think about the letters Q, D, and R, they're related to dividing. They correspond to parts of division. Anybody remember any parts of division when you divide something? There's terminology that you got to know, and we're going to be covering that primarily today. Okay. So P of x, Q of x, D of x, and R of x are polynomials. Let's just look for a minute at an expression like this. 687,251 divided by 153, let's say. Okay. So in that, there's different parts. This 687,251, that has a name. It's the thing that's being divided. It's the thing that's being divided. Anybody remember what the thing being divided is called? It doesn't. It starts with a D. It's the dividend. Yeah, the thing that's being divided is called the dividend. The dividend. Okay, it's a weird word. You probably haven't heard it since like 4th, 5th, 6th grade, something like that. But yeah, that's what it's called. It's the dividend. And of course, this means to divide. It's the division sign. The division sign. Interestingly, the division sign can also be written in this fashion, can't it? And if we wrote it that way, we would have to be careful where we put these numbers. This 687,251 being the dividend with respect to this division sign, where's it go? On the outside, the top, or the inside? On the inside, right? Everybody doing all right so far? Yeah, because that's what's being divided. Cool. I don't know if you remember how to divide numbers that way, but we're going to divide polynomials that way. So you're really going to have to understand the process, and that's what we're going to be covering today primarily. Okay. In addition to a little bit of theory regarding polynomials and dividing them, and numbers and dividing them for that matter. Okay. So the 153 also has a name. It's the thing that's doing the dividing. It sounds to me like something from He-Man, like one of the bad guys from He-Man. It ends with an R. Yeah. It's the divisor, the divisor, the divisor. I have a friend, his nickname is Visor Guy. That's actually his Twitter handle because he wears visors everywhere. I don't know why either. He's got a really nice head of hair. Most beautiful head of hair you've ever seen on a guy. He's Italian. He's got really long, black, flowing, curly hair. Anyway, the divisor. So that divisor, when we divide this way, it kind of goes down. Whoa, let's try that again. The divisor goes out here then, right? Okay. So whatever that ends up equaling is what we like to call our answer, and it's called the quotient. Good, nice. The answer is the quotient. Okay. And in long division, in this procedure here, however much space it happens to take up. The quotient is always written up top here somewhere, isn't it? Remember all that? That the quotient, the numbers for the quotient will show up top. All right. Now what ends up happening sometimes is you get another part that does start with the R. Remember the part that starts with the R, what that's called? The remainder. So if you get a remainder, back in like 4th, 5th, 6th grade, they just said just put R and then whatever the remainder is. Well, we're going to explore that. We're going to take that a little bit further, and we're going to see the best way to handle that remainder. So we're going to start with something that's really simple to divide. Something really simple to divide. Something like example 1, divide. 10 divided by 10 divided by 3. Okay. 10 divided by 3. So we would like to see how many times does 3 go into 10. 3 times with the remainder of 1. Nice, cool beans. So the interesting thing, if I'm keeping a running step by step, the first thing I need to kind of do to divide is I want to divide. That's the first step, right? Step 1 of division is divide. And what am I actually dividing here? I'm dividing 10 by 3. And that's 3. And so this 3 goes here. So if I do this long division process, what's the second step of this long division process? Yeah. I can't find the remainder yet. There's a second step to this process. I multiply. Yeah, I take this 3 here and I take this 3 here and I multiply them. So the second step in this long division is multiplying. That's kind of weird. To divide, you have to divide and then you multiply. So anyway, 3 times 3, that's 9. And then there is a third step to this. The third step, and this is where our remainder comes from, is subtract. Sure. So this is kind of unusual to divide. You're dividing, multiplying, and subtracting. So I subtract the 9 from the 10, and that's 1, and that's where my remainder comes from. Okay, so back in the day, you would write R1, right? Now, when I was in 5th, 6th grade, I remember literally crying my eyes out because I had no idea where the remainder came from and why it was that number and what to do with it. I used to get so frustrated. So if you punch in this in the calculator, you know the calculator is going to tell you that the answer is 3.3333333, and so on, right? Well, the deal is there's a better way to express the quotient. There's a much better way to express the quotient. That's okay, but we could do better. We could do better. We could take our quotient, that 3. Now, I don't know if you guys know this or not. Maybe you do. Maybe somebody out there knows what that decimal point, what 3-letter word that decimal point literally translated means. Dot, not dot. That's a 3-letter word. Last week, I had my advanced students try to read this number. And I had a prize for somebody that could read it. I don't have any prizes today. But they would say 200 and I'd say 267,000 and 267,356. Yes. Did I say that right? 267,356 is wrong. 267,356. Let me go ahead and put a decimal point. 267,356 and 25 hundredths. Do you see what the decimal point means? And, right? So the deal is the decimal point means and. And what operation does and mean in math? It also starts with an A and ends with a D and has 3 letters in it. Add. So that decimal point, the stuff after the remainder, is what gets added to the quotient. So the deal is this is 3 and 3 and 1, 3 and 1 something. 3 and 1 something. Well, what do we know 0.333333 is? Most of us know that that is 1/3, right? So that's 1/3, or 1/3. So it's that quotient divided by, and we got to be careful here, we got to make this real clear, divided by this original divisor, divided by that original divisor. So the best way to write the remainder, then, is to write it as a fraction being added to the quotient. It's a fraction added to the quotient. And when we do polynomials, when we divide polynomials, we're going to write them the same way. We're going to write the remainder the same way. So sometimes the theory gets a little confusing. It gets a little scary. So if P of x, Q of x, D of x, and R of x are polynomials, then what happens? If we had P of x divided by D of x, that's taking some polynomial, dividing it by a divisor, then that's going to equal our answer, which is our quotient, which is Q of x. And then what do we do in the event that there's a remainder? We add it as a fraction, so we add the remainder, and the remainder is over what? The original divisor, right? So this is kind of the deal, the thing that we're going to be doing with polynomials. We're going to take a polynomial, divide it by another polynomial. The answer is going to be the quotient. If there's a remainder, we have to add it, and it's going to be a fraction, and the remainder will be in the numerator. The denominator will be the original divisor. But we're not going to divide any polynomials just yet, because we need to see how to divide numbers. We kind of saw a glimpse of the process. Divide, multiply, subtract, but there's more to that process. So example 2, we're going to go ahead and do this quotient, find this quotient, 687,251 divided by 153. We're going to do that in example 2. Example 2. Example 2. 687,251. Where'd it go? 687,251 divided by 153. Divided by 153. All right. So keeping a running step by step, the first thing we need to do is divide. The next thing we need to do is multiply. The next thing we're going to need to do is subtract. And maybe I'm leaving too much room here. So we're going to divide, and then we'll be multiplying, and then we'll be subtracting. And then maybe there's something else to do. So let's see, we want to see how many times does 153 go into 687,251. Now, as good as I am at math, I don't know how many times 153 goes into 687,251. I couldn't tell you. I really couldn't. So I'm not going to look at the whole thing. I'm just going to look at part of it. And when we get to polynomial division, it's going to be the same thing. You're going to just look at part of it sometimes. I'm just looking at 687. I want to know, can I think of how many times 153, how many times 153 is going to go into 687? That's more manageable, isn't it? Okay, so how many times might 153 go into 687? 4, maybe 5? 4, okay, we're thinking 4. 4. So that's our dividing, right? We divide 687 by 153. So we think it's 4. Well, now we're on to our second step. Now we're going to go ahead and multiply that. So you got to remember how to multiply to be able to divide. 4 times 3 is 12. Carry a 1. 4 times 5 is 20. With the 1 carried, that's 21. And then carry the 2. 4 times 1's 4 with the 2 carried, that's a 6. Okay, so we divided, we multiplied. In this case, what we multiplied was 4 by 153. And now I guess we're left to do what? Subtract. And we're going to be subtracting 687, take away 612. And you got to be really good at subtracting. Some people are awful at it. 7 minus 2 is 5. 8 minus 1 is 7. And 6 minus 6 is nothing. So we're on to something. We got a good start going. One interesting thing is, right now I can kind of get an answer of how big, I can kind of get an idea of how big my answer is. My answer is going to be 4,000 something, right? Does that make sense? Because of the way the decimal points line up. And with polynomial division, you'll be able to tell pretty quickly how big your answer is going to be. For instance, if you divide a quadratic by a linear, your answer is going to be linear. If you divide a quartic by a linear, your answer is going to be cubic and that kind of thing. Okay? So there's another step. Not add. We have to do some bringing down. Okay, so there's this other step called bringing down. Because we don't have enough with that 75 to see how many times 75 goes into 153. So we bring down this 2. And then what ends up happening is that whole cycle, this whole procedure is going to repeat again. And we go back to the top of the list. And now we want to know how many times 153 goes into that. Is it just 4 again, or could we go? 5's going to be too big, thank you. So it's going to have to be 4, huh? Okay, so we go 4. Now, this is what I kind of like. I can use the 612 over again, right? Because I know that product. So that's what? 612, subtract. I'm a good subtractor. That's a 0, that's a 4, and that's a 1. All right. So we had to repeat that step again. Divide, multiply, subtract, bring down. Oh, man. Oh, my goodness. Now we got to bring down the 5. Yeah. So we're on the bringing down thing. So we bring down the 5. So now we want to see how many times does 153 go into 1405. And I'm guessing it's going to be a big number. Like, is it 9? Yeah, 8's just going to be that 612 doubled. So we're going to try 9. Okay, thank you. Good deal. So let's go ahead and try the 9 then, see what happens. 9 times 3 is 27. Carry the 2. 9 times 5 is 45. With 2 carries, 47. Carry the 4. 9 times 1 is 9. With the 3 carried, hey, look at that. That's 13, right? Okay. So we're good subtractors, I hope. I got to borrow 15 minus 7 is 8. I got to borrow that 10's now a 9. 9 minus 7 is 2. And the 4 has to turn into a 3. And so that's it. It's just 28, right? Okay. Got to bring down again. Good. So we bring down one more time. Bring down this 1. So the last time here, well, maybe not the last time, we got 281. And we want to see how many times 153 goes into that. And we're thinking 1. So 1 times 153 is 153. We subtract the difference. Let's see, that's 11 minus 3 is 8. 7 minus 5 is 2. And that's 2 minus 1 is 1. So that's 128, right? Now, if we wanted to keep on going and we wanted to get decimals, we could. And that's what you were taught back in 4th, 5th, 6th grade, right? They would have you put a decimal here and a 0 and a 0 and a 0. Whoa, let's try that again. Forgot about that. They'd have you put a 0 here and a 0 here and a 0 here. And you'd bring down and you'd get so many decimal points for your answer, right? That's a lot of energy. It's a lot of work. I'm not going to do that. because I know that I'm going to end up with an answer that's really, truly a mixed number, right? It's 44, 91, and what's the fraction? 128 over 153. Does that make sense? The process? We feel all right about it? What would you do if I gave you one of those on a quiz? Would you be able to handle that? No calculator? Just dividing numbers? Well, in a minute, we're going to put polynomials into this. Okay. There's something that I can't believe I didn't show you earlier. Related but not related. I call it the coolest thing ever. Actually, I call it the coolest thing ever. Remember back in the day when you had to evaluate a function like this? When you had to evaluate a function like this, and they said find f of 6. That means for every x you see, you're going to have to plug a 6 in, right? So what you would do is you would say, okay, so this is negative 2 times 6 cubed plus 6 squared minus 5 times 6 plus 11. And in this process, you have to take 6 and cube it. That's 6 times 6, which is 36 times 6, which is 216. So this is negative 2 times 216 plus 36 minus 30 plus 11. So 216 times 2, that's 432. That's negative 432 plus 36 minus 30 plus 11. So that's going to be, oh gosh, I don't know, negative. Can I just go ahead and make this a 6? Would that be all right? Yeah, make that a 17. I'm going to leave that a 6. Negative 432 plus 6 plus 11. So that's negative 426 plus 11. So that's negative 415. Does that seem right? Negative 415. So doing those takes a lot of work, takes up a lot of lines in your notebook paper, doesn't it? What would you do if I told you could evaluate that without having to subtract, without having to cube, without having to square, just by adding and multiplying? Would you believe it? Is it something you wish your teachers would have shown you back in the day? Back in 8th grade? Heck yeah. So, this is the coolest thing ever, I think. And I don't know, for whatever reason, it always reminds me of Snoop Dogg. We need a box like this, and some people make their boxes different, but I have a box like that. And I need a line like this. Now, we were finding, what were we asked to find? We were asked to find f of 6, right? So, what I'm going to go ahead and put in this box, and I'll highlight where these things are coming from. I'm going to go ahead and put a 6 in the box right here. Okay, I'm evaluating the function for 6, so I'm going to put a 6 in the box. Now, this process is awesome because I don't have to square anything. I don't have to cube anything. I don't have to divide. I don't have to subtract. All I got to do is multiply and add. So this negative 2 is going to go right here. All I'm doing is grabbing my coefficients. Okay? So this coefficient, what's that coefficient? 1. Okay? A lot of people think it's a 0. That coefficient's actually 1. Okay? And then my next coefficient is negative 5. So I got a negative 5 there. And then I do want to use a highlighter on this. And then the 11, right? So there's 11. Everybody see the setup so far? Okay. So the reason that this reminds me of Snoop Dogg is because he had this one song back in the day, and he was pouring Sean John with the rollie on the arm, And what's the name of that song? Ooh. With the rolling on the arm and the pouring Sean John. Not gin and juice. Drop it like it's hot. Anybody remember that one? Drop it like it's hot. So anyway, the first step in this procedure is we're going to take this -2 right here and we're going to drop it like it's hot. It's going to go underneath the bar. This is always going to be true of this procedure. That first coefficient is always going to be dropped to below the bar. And then, what did I say the procedure was? All you have to be able to do is multiply diagonally. When you multiply, you're going to be multiplying in a diagonal fashion. Diagonally. We're going to be multiplying on a diagonal. And then we're going to be adding. So we're going to be multiplying diagonally and adding oh my gosh, smartboard, work with me. Oh my gosh, I better write it over here. Vertically. We're going to be adding vertically. Okay. So what the heck is this multiply diagonally and adding vertically all about? Well, this 6 times this -2, that's the diagonal multiplying. What's 6 times -2? -12. And that quotient is going to go up and fill in the spot of the line right here. Okay. So add vertically. What do you mean add vertically? I mean, with this adding vertically, I'm going to go right down this column. What's 1 plus -12? -11. Now notice, did I have to square anything yet? Did I have to cube anything yet? Did I have to multiply, or did I have to divide anything yet, or subtract? No, I'm just multiplying and adding. So again, multiply diagonally. 6 times -11. It's -66, and that's going to go up to here, so that's -66. Add vertically. -5 plus -66. It's -71. So that's -71. And lastly, multiply it diagonally. 6 times negative. Now 6 times 71 is kind of tough, but 6 times 7 is 42. So that's 420 and another 6, right? So that's 426. That's 426, and it's negative, right? Add down the column, and what do we get? -415, which is what we got before. What? No freaking way. You mean to tell me that instead of having to cube and square and subtract and do all that stuff, I can just do this process and I'll get the same answer? Yes. Why didn't your 8th grade algebra teacher show you this? Or your 9th grade algebra teacher show you this? So in case you're wondering what this coolest thing ever is called, it's called synthetic. It's called synthetic substitution. Some people call it the remainder theorem or something like that. I don't know. I call it synthetic substitution. I think it's awesome. So suppose P of x is negative x to the 5th plus x cubed minus 2x plus 4. And you had to go ahead and find P of -3. So let's go ahead and try one of these. Let's see if we can do this. So remember, we're going to set up our box. It's like an L on its side. The line is kind of below it and beside it. So whatever we're evaluating for is what goes in the little L bracket. So what's going to go in the L bracket? -3. Now I got to be very. I gotta warn you. There's a caveat to this. My advanced class, they just took their chapter test, and some of them did horribly because they didn't understand the idea of placeholding. We're going to be using our coefficients, no doubt about that. You can believe it. You can take that to the bank. What's our first coefficient going to be? -1. Now notice that there's no quartic term. Because there's no quartic term, we have to occupy the place of the quartic term with a placeholder. with its coefficient, which is not 1. If it was 1, that would be there. It's going to be 0. Okay? Because there is no quartic term, its coefficient is 0. So that's why we need a 0 to hold the place of the quartic term. So what's our next coefficient going to be then? 1 for the x cubed. 1 for this x cubed. Good. And then what? Well, there's no quadratic term, right? So aren't we going to need a 0 placeholder for the quadratic term? And then what? -2. That's that coefficient of the linear term, -2. And then 4. Okay. So placeholding is a very imperative thing. Now remember, the last entry that you get down here, that's going to be your answer. That's going to be what P of -3 ends up evaluating to be. So how's this whole thing start? What do we do? Drop the -1 like it's hot, as if it were hot. So the -1 goes down here, and then what? Multiply diagonally. So -3 times -1 is 3, and that 3 is going to pop up to here. And what do we do with the 0 and the 3? Add vertically, add down the column. So that's going to be a 3. Multiply diagonally. It's -9. Add vertically. It's a -8. Good. Multiply diagonally. 24. And then what? Add vertically, so we get 24. Now, 24 tripled, that's 72. Good, and it's negative, right? So we got -72. Add vertically. -74. Now, again, if you can't multiply 74 times 3, don't sweat it. 7 times 3 is 21, so that's 210. 4 times 3 is 12, so that's what, 222? And it's positive, right? So that's 222. So our answer then would be 226. 226. We didn't have to raise anything to the 5th power. Thank goodness. Who wants to raise -3 to the 5th power? I know I don't. We didn't have to cube anything. We didn't have to subtract. All we did was add it and multiplied. Now, just in case there's doubters out there, people who don't believe that this really works, I'll verify it with my calculator. Right quick. And then the last thing we're going to do today is see if we can just take one quick look at a polynomial division. Okay, so our function we were looking at was -x to the 5th. Was it plus x cubed? Plus x cubed. And then what? -2x plus 4. Thank you. -2x minus 2x plus 4. Okay. And we went ahead and found P of -3. So I'm just going to go to the table. And when x is -3, there it is, 226. We got him. We did good. Isn't that the coolest thing ever? We're going to revisit that, so don't forget how to do that. We're going to look at that again in 2 days' time. So here's our last example. Last example of the day. Last example today. We're going to go ahead and take something like 6x to the 4th minus 2x cubed plus x squared minus x plus 1. And we're going to divide it by, 2x minus 1. So if we took something like 1,000 and divided it by 100, our answer should be 10 something. If we took 100 and divided it by 10, our answer should be 10 something in the tens. If we divide a quartic by a linear, how big should our answer be? A quartic divided by a linear, how big should our answer be? Yeah. Cubic, nice, good. So those are the kind of things, the number sense things that I want you to kind of start realizing. Okay, so 2x minus 1 is our divisor. 6x to the fourth minus 2x to the third plus x squared minus x plus 1 is our dividend. Now, it looks pretty overwhelming to try to figure out how many times 2x minus 1 goes into all of that. It looks very overwhelming. And it also looked overwhelming when we tried to see how many times 153 went into 687,251, didn't it? So we didn't look at the whole thing. We just looked at part of it, didn't we? So that's all we're going to do. We're just going to look at part of this. We're just going to look and see, okay, I know that I'm going to have to see how many times 2x goes into 6x to the fourth. How many times does 2x go into 6x to the fourth? So that's the first step of dividing. The first step of dividing is divide. And in this case, we're dividing 6x to the fourth by 2x. So it's going to be 3x to the third. Good. So it's going to be 3x to the third. So where we put this is totally up to you. Now, some people like to have all their cubic terms lined up. So would it make sense to go ahead and put that right here? Okay. So when you do this, it's real imperative that you have vertical alignment of everything. So the first step was to divide. Now our second step, if you're keeping track, is to go ahead and multiply, right? So when we multiply this, we've got binomials. We've got this monomial times a binomial, so we're going to have to use the distributive property, right? So that's going to end up giving us 6x to the fourth. And then what? Minus 3x to the third, right? The number one place where students mess these up is they're horrible at subtracting. And that's why I like the coolest thing ever, because you don't have to subtract on those. But on this, people are awful subtractors. You're subtracting this whole quantity. 6x to the fourth minus 6x to the fourth, those cancel. That's pretty clear. However, the number of x cubes that remain, a lot of people mess this up. They think it's minus 5x cubed. No, it's not. What you've got going on is you've got negative 2x cubed minus 3x cubed. Minus 3x cubed means we're adding 3x cubed, doesn't it? So this is going to be x cubed then. So we multiplied, we divided, we subtracted. What's next? Bring down, good, yeah. Bring down, so we're going to go ahead and bring down this x squared. So we went ahead and brought down. And then the whole thing starts over again. Divide, multiply, subtract, bring down. But again, we're not looking at everything. We're just looking to see how many times does this 2x go into this x cubed. Oh, this is tricky. X cubed divided by 2x. Isn't it going to be something x squared? Would it be 1/2 x squared? 1/2 x squared? Okay. So this is plus 1/2 x squared. Plus 1/2 x squared. All right. So 1/2 times 2 is 1, and x squared times x is x cubed, so that's going to be x cubed. A half times 1 is a half, that's going to be minus 1/2 x squared. And I'm going to go ahead and subtract. So I have 1x squared, I'm subtracting from it minus 1/2 x squared. So 1 minus a half is going to be 1 plus a half, or Isn't that going to be 1 1/2 x squared? I normally don't use mixed numbers, but I'm going to go ahead and use them here. So that's 1 1/2 x squared. And then what do I do? Bring down, good. Got to bring down this minus x. Do you get the idea? This one's not going to work out so nice, but do you get kind of the idea? Tomorrow we're going to start off with some easier examples of this this polynomial long division. Honestly, I don't think it's that bad. So tonight, what I'd like you to do is kind of look back over your notes. This synthetic substitution, the coolest thing ever. Maybe make up a few of those on your own to practice. Be able to divide a number like this. Tomorrow at the beginning of the class, there might be an introduction ticket. Divide just some numbers like that at the beginning of the class. It's been real. It's been fun. Have the best day of your lives. See you. Anybody want to give a shout out real quick? Shout out to the future Mr. Minnick for being awesome. Any other shout outs? No shout outs. All right. Well, that's it. See you. Good.